Big Boy 4014 is out there right now, rolling through the country in 2026, and if you've seen it, you already know. The ground moves before you even hear it. Then that sound, that pressure in your chest, a force of nature wearing steel right in front of you. If you haven't seen it yet, get yourself to a stop on this tour. Seriously. But whether you've been trackside or not, you've probably thought the same thing everyone thinks about that machine. This is the pinnacle. This is as good as steam ever got. Here's the thing. Union Pacific agreed with you, and that's exactly why they tried to kill it. By the early 1950s, Union Pacific's engineers weren't building bigger steam locomotives. They were sitting in a room with General Electric, sketching out something that looked less like a locomotive and more like a jet engine strapped to a set of freight wheels. A machine that would eventually produce 8,500 horsepower, more than the big boy's output, burning fuel so filthy it was essentially industrial waste. This is the story of Union Pacific's gas turbine-electric locomotives, the most powerful single-unit locomotives ever built on American rails, and the machines that history almost completely forgot. If you've been trackside watching 4014, you've been watching a survivor, a preserved ambassador. What you aren't seeing is the operational nightmare that locomotive represented in the late 1940s. Steam locomotives, even the magnificent big boys, required armies of labor to keep running. A fireman, a hostler, a full mechanical crew every few hundred miles, enormous amounts of water, and Sherman Hill in Wyoming is not exactly the Amazon basin. Then there was coal, rising fuel costs, brutal maintenance intervals. A big boy coming off a hard run over the Wasatch went straight into a shop that needed to be staffed around the clock. The economics were cracking, but Union Pacific didn't want to just replace the big boy. They wanted to embarrass it. Something so far beyond it that the comparison would be almost insulting. So Union Pacific's motive power department looked at the emerging jet turbine technology of the post-war era and asked an audacious question. What if we did that, but for freight? General Electric had been developing gas turbines for aviation. Proven technology, extraordinary power output. The only question was whether it could survive the brutal, dirty reality of heavy freight railroading. In 1948, Union Pacific and General Electric signed on together. A gas turbine spins at enormous RPM. That energy drives a generator. The generator powers electric traction motors at each axle. No pistons, no valve gear, no complex steam circuits, just spin, generate, pull. On paper, it was genius. The prototype arrived in 1948 and was tested through 1949. It worked. By 1952, the first production units arrived, 10 locomotives at 4,500 horsepower apiece. 15 more followed in 1954. For context, Big Boy produced somewhere in the neighborhood of 6,500 to 7,000 drawbar horsepower at peak. So those first turbines weren't even beating the Big Boy yet. They were the opening move. Crowds came anyway. The future of American railroading had arrived, wearing a yellow and gray paint scheme and making a sound unlike anything that had run on American rails before. The crew on these things? 2 men. Where steam demanded 5, 6, sometimes 7, the gas turbine needed a driver and a helper. Union Pacific was pleased but not satisfied. They wanted the number that would truly bury the big boy, so they went back to General Electric and asked for more. In 1958, the third generation arrived. 30 units, built as 2-unit, 6-axle sets, putting out 8,500 horsepower. Nearly double the first turbines, and now decisively beyond anything the big boy had managed. These were the Big Blow turbines. People said they sounded like a jet airliner taking off right there on the ground. In some California communities, the noise got so bad that local governments effectively forced Union Pacific off certain routes. Then someone checked the fuel receipts. 14 to 17 gallons of oil. Per mile. Not per hour. Per mile. And these turbines burned nearly as much fuel idling as at full throttle, which meant Union Pacific had to keep them constantly working just to make the economics function. They ran on Bunker C, the bottom of the barrel residual left after refineries extract everything useful from crude. Cheap, practically industrial waste pricing. That was the entire justification, which was true, until it wasn't. Bunker C is not clean. Ash, particulates, sulfur, metallic compounds. In a stationary boiler, you manage that. In a turbine spinning at operational speeds, you suffer it. The blades were being destroyed from the inside out. Ash and grit hit those precision-engineered blades at high velocity every hour. Blades that should have lasted thousands of hours degraded far faster than projected, at costs that made the Ogden maintenance crews nervous. Union Pacific eventually tried a cleaner fuel oil to fight the erosion. It never fully solved it, and Ogden itself was a problem. Steam maintenance required skills practiced for 60 years. Turbine maintenance required something closer to aerospace engineering. Special tools, special training, parts that took weeks to arrive from the east. When a big boy broke down, Union Pacific's shops could usually fix it. When a turbine broke down, it waited. Then there was the smoke. Bunker C combustion produces a dark, thick particulate exhaust plume, nothing like clean diesel heat shimmer. Communities along the route complained. Union Pacific was operating machines that looked, to civilian eyes, like rolling industrial chimneys. And while Union Pacific wrestled with turbine blades and Bunker C politics, General Motors' Electromotive division was doing something far less dramatic and far more dangerous to the turbine program: iterating. Quietly. Diesels of the late 1950s and 1960s weren't as powerful unit for unit, but they were reliable, predictable, and serviceable by any good diesel mechanic. Union Pacific had hundreds of those. Diesel horsepower crept upward every year, and diesels could be coupled together with redundancy. If one failed, the others kept pulling. If a turbine failed, the whole consist stopped. Union Pacific kept all 55 turbines running through most of the 1960s. They weren't ready to admit the experiment had a limit, but the fuel markets were already deciding for them. Through the late 1960s, the petrochemical industry found new uses for those heavy residual oils, especially in plastics. Bunker C wasn't free industrial leftover anymore. Demand climbed, and so did the price. The math that had justified 14 to 17 gallons per mile was eroding, year over year, well before anyone had heard of an oil embargo. Starting in August 1968, Union Pacific began quietly retiring the fleet. Not in one dramatic week. Unit by unit, batch by batch. The last operational run of an 8,500 horsepower turbine came on December 26, 1969, hauling freight from Cheyenne to North Platte. The final units were formally retired in February 1970. The most powerful freight locomotives on the continent sat cold in yards, while Union Pacific's diesel fleet absorbed the workload without ceremony. Most of their running gear was recycled into General Electric's new U50 and U50C diesels. Fittingly, Union Pacific's next attempt at chasing that same horsepower number with conventional power. These machines never truly failed at their job. They moved freight, they climbed grades, they produced the power they were built for. They were killed by a slow-motion economic squeeze, a fuel source whose rock-bottom price was never going to survive the rest of industry figuring out what to do with it. 2 of the 55 survived. Number 18 is preserved at the Illinois Railway Museum in Union, Illinois. Number 26 sits at the Utah State Railroad Museum in Ogden, just miles from the shops that once struggled to maintain it. You can walk up to it, stand in the cab. If you've seen Big Boy 4014 on this tour, you're looking at a locomotive that outlasted the machine built specifically to embarrass it. The thing that was supposed to make the Big Boy obsolete exists now in 2 museum pieces, while 4014 tours the country drawing crowds in the thousands. History has a sense of irony. The gas turbines were ambitious in a way American industry rarely allows itself to be anymore. Engineers looked at the biggest locomotive ever built and said, "We can do better." By the time the 3rd generation arrived, in raw horsepower, they were right. But being right about engineering and being right about economics are 2 different problems. And in railroading, the economics always win. If this kind of deep dive mechanical history is what you're here for, hit that like button and tell me, if Bunker C had stayed dirt cheap forever, do you think the turbines eventually solved their maintenance problems and pushed diesel off the main lines? Or were the
gas
mechanical limits
turbines
too
provided
deep
more than
regardless?
enough power to pull
Drop your
huge
answer
loads
below.
through some of the
Subscribe
country's
if you
most
haven't already.
mountainous terrain.